My name is Mary Hayden, and I'm a research scientist in RAL. So I'm going to be introducing you today to just one aspect of our weather, climate, and health program in RAL, and it's the case of dengue fever. So weather, climate, and health they've always been integrally connected. And with global climate change, we're seeing definite negative impacts on human health based on changes in our weather and our climate. And we expect these to increase. According to the IPCC projections, we're going to see an increase in frequency and intensity of health threats, and these are going to have a negative impact on human health. Dengue viruses, which is what I'm talking about today, cause an estimated 90 million cases of dengue fever annually. Dengue is known as breakbone fever, in case you haven't heard of it, because it feels as if every bone in your body is breaking when you get this disease. The mosquito vector, Aedes aegypti, is expanding its range in the Americas. And in order for dengue to emerge, we need Aedes aegypti, we need humans who are susceptible, and we need the dengue virus, all in an environment that is conducive to each one surviving independently and together. We're seeing a shift in the dengue transmission cycle these days with an urban cycle with the growth of megacities, with a lack of infrastructural amenities available to us, and a susceptible human population. So we see a reduction in vector control or mosquito vector control, and this causes problems. We've seen a 30-fold increase in dengue in the last 50 years. And we've seen that in 2010, actually, we saw 96 million cases of dengue, 13 million of those in the Americas. So the mosquito vector, Aedes aegypti, is a human commensal organism. It only bites humans. It feeds during the daytime. It rests indoors. It feeds on people indoors. And so it's a very dangerous mosquito. It also is linked very closely to weather because of its close-knit contact with humans. So it exploits artificial containers such as tires, breeds in and around homes, and we see that max and min temperature are really important in the development of the mosquito itself. This graph is showing you temperature on the x-axis and other factors that influence dengue and climate on the y-axis. So, I missed a slide there. So including physical and social parameters, spatially varying and dynamic indicators into disease risk assessment is a challenge, but it needs to be systematic, it needs to be integrated, and it needs to be stakeholder driven. And in order to do that, we need to utilize an integrated approach for this that brings together multiple disciplines and provides a systematic mechanism that helps us address these real-world problems like dengue fever. So the next map is going to show you a north-south gradient for minimum and maximum temperature, as well as disease incidence in Hermosillo, Mexico. And advances in remote sensing, in GIS technology, and disease surveillance give us better tools for this type of risk mapping of diseases. This map shows a simulation of dengue cases in Hermosillo, Mexico as a function of temperature and precipitation. The simulation captures fairly well the cases of dengue, but some of the things that are missing are the socioeconomic factors that are much more difficult to bring into models. So when we're looking at risk, we're looking at trying to better understand how we prepare for risk, how we respond to risk in the short term, as well as when we're talking about adaptation in the long term. And one of the things that's really important is the importance of scale. And so how these risk assessments are used and by whom really determines the scale of analysis. And so from our experience, using a top-down and bottom-up approach is what's really needed. Local level assessments, community-based assessments help us to focus on specific cultural and social contexts that are critical to better characterize our adaptive capacity. Okay, so municipal and regional level assessments are also important because they allow us to do a more generalized inter-comparison of risks and stresses. And here's where we can also bring in issues surrounding climate change. So national and global assessments provide a big picture of health hazards and vulnerabilities at the scale that most closely matches projections from our global climate models. So by integrating the physical and the social sciences, we are able to provide both useful and usable assessments of the complex dynamics of diseases like dengue fever.